All right, so the function P of t models the population of the world in billions of people, where t is the number of years since January 1, 2010. Which of the following is the best interpretation of the statement P prime of 1 equals 0.076? Okay, so if P of t represents the population, then P prime of t will represent the change of the population. So P prime of 1 represents the change of the population when t equals 1, or represents the rate of the change of the population when t equals 1. And since t is the number of years since January 1, 2010, that means 1 year later. So P prime of 1 is basically saying that on January 1, 2011, the rate of change of the population is 0.076 billion people per year. And so that would be B. Right, so we have f is a differential function with these values given in the table shown here. So what's the average rate of change over the closed interval from 0 to 10? All right, so that's basically just going back to your regular Algebra 1 class for like slope. Like slope is basically the rate of change in y over change in x. In this case, change of f of x over change in x. So you're basically going to look at f of 10 minus f of 0 over the change in x, so over 10 minus 0. F of 10 is negative 20. F of 0 is 5. 10 minus 0 is 10. This is negative 25 over 10, or negative 2.5. So the answer will be B. All right, the rate of which motor oil is leaking from an automobile is modeled by the function L, and it's defined by L of t is equal to 1 plus sine of t squared for time t is more than or equal to 0. L of t is measured in liters per hour, and t is measured in hours. How much oil leaks out of the automobile during the first half hour? Okay, so this is a good example of how we can use integration. So to figure, the total amount that leaks over a period of time, we're just going to integrate this function over that period of time. If we're saying the first half hour, we're going to integrate from 0 to 1/2 hour, or from 0 to 0.5 hours. And our function is 1 plus sine of t squared dt. And since this is a calculator problem, or you're allowed to use calculators on these problems, we'll go ahead and use our calculator to do it. So let's go to the menu, numerical integral, set our boundaries from 0 to 0.5, and make sure we enter our function correctly. So 1 plus the sine of, and we'll just use x in this calculator. Oops, the x. 1 plus sine of x. And we'll get about 0.541. 481. That would be D. All right, the table gives values of the differential functions f and g and their derivatives at x equals 0. If h of x is equal to f of x over g of x, what's the value of h prime of 0? So let's first just find what h prime of x is equal to. And this is essentially just going to involve the quotient rule, which tells you that when you have a quotient of two functions, the derivative of the quotient, in this case the derivative of h of x, will be the bottom function squared, so g of x is the second power. And in the numerator, you're going to have f prime of x times g of x minus f of x times g prime of x. Now, since we want to evaluate h prime at a specific value of x, we're just going to evaluate these at x equals 0. So our equation will look like f prime of 0 times g of 0 minus f of 0 times g prime of 0 all over g of 0 squared. And we can use our table now to find those values. So f prime of 0 is 4. G of 0 is 2 minus f of 0, which is 3, times g prime of 0, which is pi, all over g of 0 squared, so all over 2 squared. So you're going to end up getting 8 minus 3 pi over 4 as your answer. And so that'll be A. Right, number 80. All right, so here we have the graph of f prime. That's going to be the derivative of f for values of x from 0 to 2. So what value of x does the absolute minimum of f occurs? So let's remember and understand that the minimum of a function occurs, when the function is, at its basically lowest point. So maybe you have an example of a function that goes like this. This would be a minimum. And the idea is to recognize what the function is doing before the minimum and after. For it to be a minimum, in general, the function is going to be decreasing, and that means the derivative will be negative. So over on this side, f prime is going to be less than 0. After the minimum point, f prime is going to be positive because it's going to be increasing. So negative before and positive after. It doesn't always have to be like this simple, but that's the general idea for a minimum to occur. So let's make sure that we recognize this is not a graph of f. This is a graph of f prime. So this is a graph of f. This is an example of a graph of what the graph of f would look like. So since this is the graph of f prime, we want to see where the graph of f prime goes from negative values to positive values. So all along this region, all here it's negative. Over here it's positive, but this wouldn't be a minimum. This would be a potential maximum or local max. After we get past the negative values and over here, then this would be a potential minimum. And since that's the end, that's going to be where our absolute minimum on this interval would occur. So the minimum would be over here. And so our answer will be E2. All right, 81. What's the region? What's the area of the region enclosed by the graphs of y equals the square root of 4x minus x squared and y equals x over 2. Okay, so for this, let's go ahead and let's use our calculator to graph this. So we're going to go to our graphing function. We have y equals the square root of 4x. We'll graph the other guy. Y equals x over 2. And so then we want to find the region in there. So we want to find what that left endpoint and right endpoint is going to be. Let's just draw a sketch of what's going on here. So we'll have something like this. Like that. Now this left point will be 0, and we can already easily figure that out. So we want to figure out that point there. So we can, in this calculator, you can use the analyze graph function and look for the intersection. the lower bound, scroll to the right. And we can see our intersection is right about 3.2. We could probably zoom in to make it a little easier to see. About 3.2. Okay, so this just then lets us know how to set up our integral. So our integral will be from 0 to 1 or 0 to 3.2, and we're going to take the top function minus the bottom function. The top function is this, so we're going to set up our integral as the square root of 4x minus x squared minus the bottom function, which is the x over 2. And we're going to integrate that with respect to x. So we'll use our calculator for that again. Go back to the calculator screen, go to calculus, numerical integral from 0 to 3.2. Minus x divided by 2. Let's make sure that I didn't make a little mistake. Let's see what we get. We got 2.8285. Or 2.8, yeah, 2.8, and that would be B. The closest answer would be B.